So here's another proof, and this one's a little bit different. But we have suppose that for any epsilon greater than 0, so this is just any positive number, and we're going to call it epsilon, a is less than b plus epsilon. Then a is less than or equal to b. So here, it may just be personal experience, but when I see a proof or a question in this form, I typically either think contrapositive or a contradiction. And I'm getting a sense that contradiction will work here, and I'll explain it a little bit in a minute, but let's start with a contradiction. So we're going to assume the negation of this statement. And we're going to hope to get a contradiction when we try to reach here. If we reach a contradiction, then it must be the original statement. So we're going to assume, instead of a is less than or equal to b, we're going to do the negation. So a would be greater than b. Since a is greater than b, by axiom 2, we can add negative b to both sides. All right, if you want to think of it as subtracting b on both sides, that's totally fine. I'm just trying to be consistent with the axiom. So what we can do this, subtract negative b, or add negative b, and we get a minus b is greater than 0. Okay, and what we're going to do is we see that for any epsilon greater than 0, this should hold. Okay, well, this is any number that's bigger than 0, so let's let that be our epsilon and see if it holds. That's kind of the technique for these. We're going to try and pick an epsilon and see if we can get a contradiction, because this should work for every epsilon that's greater than 0. So, okay, here's a number greater than 0, right? So let's try it. So we can say, let epsilon be equal to a minus b. So if we do that, we get a is less than b plus epsilon, and we can substitute. So then a is less than b plus epsilon can be rewritten. So let's do that. We have a is less than b plus epsilon. We're going to take epsilon and replace it. So we're going to have a is less than b plus, instead of writing epsilon, we're going to have epsilon equals a minus b. And we can clearly see that this b will cancel, and we are left with a is less than a. And this is a contradiction. So we've just shown that there is an epsilon value greater than 0 where this doesn't hold. Therefore, we have a contradiction, and thus a has to be less than or equal to b.